So hi, once again, my name is Jakub. This is how you can contact me. You will get the link to my GitHub repo also in the end. So today I'm going to talk about CoreOS. First, I'll give you some why CoreOS. It's 7-8 months ago when I started thinking that we should need start using CoreOS in a cluster. I thought, okay, but I need just a really simple operating system to start the containers, and I don't want any fancy things in it like Python and so on. So I started looking, and the first thing that drew my attention was Atomic, but I read somewhere that CoreOS is better, so that's why I fell in for CoreOS. So I'll lead you through some basic functionality, why it's different to other operating systems. I'll show you how you can provision, because if you are provisioning operating system in a cluster, you need to make it it's sure, and why I think it's very good for provisioning in a cluster. And I also introduce you some of their services. It's not really all services. They have about 60 different services on their GitHub pages that you can follow and try. But those are the main services. I think they're one of the first. You can use them as well as separate projects. Like if you don't like CoreOS, you can still run Fleet or etcd on your cluster, and I will demo those system. So the basic thing, what I said, that it's really minimal. So if you run the pure CoreOS, it has just it requires just one. Last time I checked, 114 megabytes of RAM, and it doesn't have things like Python or anything installed, and you cannot install it. Well, you can in your home or whatever, but slash user is really locked, so it's loaded as read-only. So you cannot install another service if you like. You cannot do just some apt-get install Python, apt-get install Apache, whatever. It's not possible. It's hard in the beginning, but then you realize that all you need for anything is Docker. You like Python 2, Python 3, you just run the containers on it, and that's all you can do. CoreOS has kind of a special feature. It's auto-updating. So you specify which release version you want. You can have alpha, beta, or stable, and you can set that you want the server to automatically update. So when it updates the service, you get clustered nodes. Say 5, and when there's a new release, they will find out that there's new release. They will start downloading the new images, and once it's downloading, it's gonna say to the cluster, "Hey guys, I'm the machine 01, and I'm going to restart myself." So it will restart and immediate. The upgrade doesn't take more than just a restart. I don't know if you have virtual machines, it's very easy. If you have some hardware. Does anyone have hardware? Is anyone still using physical hosts? No? Yeah? 1, 2? Oh, 3. Okay, yeah. For you, it might be take longer to restart the server, but that's all it takes. I didn't do it because I'm running it on Amazon and autoscaling group, so it's a little bit trickier, but you can have this feature if you want. Yeah, and the rest functionality is in the containers. So how is the CoreOS clustered? It's clustered by etcd. Anyone heard about etcd? Yeah, do you like it? Yeah, okay. So I'll show you some demo about etcd, how it's used, and how it looks like later on. For now, just imagine that it's key value store. It's database similar to Zookeeper or Console. It's really basic stuff. I told you about release channels, and yeah, and the point that you have a cluster, you get the same release channel, so you can be sure that all applications that are on the host installed are the same. Because the disadvantage that you cannot install or upgrade one application is also advantage, because you know what application versions are on all hosts in your cluster, if they are not in the state of upgrading or whatever. But it's not a majority of time. So that's it. So the first service that I'm gonna introduce is etcd. You can think of it as that you can usually people store just configuration in it. So you get the configuration tree. There is a config database. You can say database username, and then there is a value. So it's stored in the cluster. It started by default on hosts. So it's using. It's not mentioned here. Yeah, it's using Raft consensus. So you don't really have to care much about how it's distributed. But I'll say about it later. Yeah. The cool thing that you have an application which is running, and you can set up. Okay, we have a config database, whatever, and when this database changes, what we will do? We want to deploy the application web servers, for example, or some API to connect to a new database. So in that application, you can just watch this endpoint config database, and when it changes, you just reload the application. Yeah, reload the application service, whatever, and you keep on listening or communicating with new database endpoint. That's as simple as that. So I think every CoreOS cluster should have this one running, or must have. But you can also use it for your own applications. It might not be the safe, so you can use the Docker containers that are running another etcd cluster, so that the OS level and application level are separated. But I'm using one for this demo. And the interface, it has some client, and you can use REST API to communicate with that, or I usually just use etcd CTL, which is client for that. And a little bit about, so I said you don't have to care much, because it's a normal master-follower setup, and by default, any member in the cluster can become a master, and election is done by a Raft consensus algorithm, which is quite tricky. If you start using it, you really should read a little bit about how it really works. So anyone used some database like that? Because it works that it needs the majority of the nodes to be up to elect a new master if master fails. So yeah, and it's really good to know if your operations how that works. So the demo, cross fingers for me. So, hello. Shit. It's not recording. Hi. So, is it? I wanted it to be on the video. So, do you think you can still hear it from the? No. No. So. So I'll do just. I will not pretend I stand straight up. So, okay. So this is the repository that will be available. You will see later in the slides. There is a repo. Sorry. Basic thing is that you go to the directory and you write Vagrant up, and you should get something like this. You should get free VirtualBox images running, or you can use VMware, whatever. Yeah, I have VirtualBox. So the first demo, I also made a little script. So you saw those free servers. I can log into them like Vagrant 1, Vagrant 2, and Vagrant 3. I'll use for this demo just Vagrant 1. So what was it? Yeah, no. It's just etcd. You can see that systemctl status etcd. If something is not working from this demo, it's probably because etc is not running, but it is running in this time. Hopefully it will stay this way. So yeah, well, can you see it? Should I make it larger? Yes? No? No opinion? Yeah. Okay. Also, so as I said, I'm using ECT-CTL client for that, and I'm using just a list. You get you know, many basic, like make there, remove there, more or less Unixy way to do things. So etcd-ctl to list the tree. You can see there's some CoreOS folder. We will not care about this, but I created the endpoint test. So I can also get the value, which is saved in the get in the test using the get. You can't see it? Better? I should look. Okay, I'll try to say as much high as possible. I don't mean as high, but yeah. So you can see there is in the root. You can think of it as a normal file system. So you get you can list it and you can get the content of test. It's not very nice example, so I can use a set. Say set into test something like. Let's see. Yeah, and you can get the value. The cool thing, I'm now on the core 02, right? So now if I go to core 01 and I do etcd ctl get test, it will give me the same value because it's clustered and automatically one of the nodes is running the etcd service, which is master, and the rest are just listening and writing the logs and having the same value. So the value is here in etcd. You write on one host or one endpoint. You don't even have to write from the host itself. You can write from anywhere else using REST, HTTP, whatever. And that's why it's really cool for configuration, because once you write it from one point, you get it anywhere else. So, little example. Yeah, test get. So I will run the. I'll run the container on one of the hosts. Yeah. Say on 02. And everyone knows the command. It just runs the container in interactive mode. It exposes port 5000. It mounts etc IP and etcd-ctl. And the image name is just Python that you can download from anywhere. And I'm running the bash. So that's it, what I have. So, but I've already done this, but basically I'm just downloading this this file, which is the Flask application. Even though I'm operations, I can write really nice programs. It services, it runs. It's well, it has some bugs maybe, but all it does, it opens the file that's from input and it returns its contents. So that's how I would like to. Demonstrate the basic thing that you read. Yeah. No. Yeah. What I'm doing actually here, that I'm calling etcd-ctl. I'm getting the value test and I'm piping it into /test. So. Yeah. So now if you are on this host and you get a test, it's hello world, and if I cut the file test, it's hello world as well. So nothing special. So I'll just run the application. It's going downloaded, the gist that I showed you, this one, and run it. No? Or did I? Yeah, I just outputted it. So now I will get the content of the test and run the application itself. So the application is running appy and the input value is /test. So if I'm lucky and it's listening on 102, not good. 402, it should be listening. But it's doing something. No, it's doing nothing. But it will ruin all demo for you. Okay, I'll try to run it as well on the second host. Sorry. Okay, not cool. Let me just try to stop. Hold. It never happened before. Do you believe me? So this is just demonstration of how we will try it home when it will be working. Yeah. So what Vagrant files, more or less what I've downloaded from, if you search for Vagrant and CoreOS, you'll get more or less this this file. So most of the setting is done here in the beginning, that you set up a number of instances, which you can also override in the config RB. It just reads this file and overrides the values. So I get the number of instances free, and some basic info. So the magic happens. It's just some presetting, and yeah, here it's starting the number of instances. It's setting the IP address that it should be listening and wasn't listening. Yeah, VM network, forwarding ports. Yeah, here's the IP address and so on. Yeah, that's you have been waiting for. Thank you, thank you. That's not all. That's not all. More is coming. There's some problem with networking, probably. So yeah, what it did, it read information from the /test file and it showed it up. Okay, but if you want to change it, this is not really cool. And to do it again, you would need to restart the Docker container and do the magic again. So luckily, this will work. I've created some startup script that you can run from here. So what I'm doing here is that I'm just getting the value from the /test from etcd and writing it into /test. And it's doing it all the time while true. And then killing the old instance of running Python or Flask, and then I'm running it again. And then I have this etcd ctl watch, which is actually watching /test directory and waiting for it to change. When it changes, it reads the value, and it's a really clumsy way I do it. I just let the loop finish and restart the application again. So the demonstration should go just. So I got the application running, yeah, and that's what it should do. It should just run. You saw it was listening and so on. So now I'm running on SSH core 1, and I will go to core 2, and I want to change the value in the etcd, and I hope it will change the value in /test and show it in the Flask application. It will be successfully restarted. Now we are crossing the fingers. Hey, the change happened. Yeah, the first successful. Cool. So this is how you can play, and that's it. Yeah, but yeah, that's the end of demo, and I hope you got some overview of how the etcd is working. Now the etcd is just a storage, but the operating system is also having by default Fleet, which is if you've been using systemd, you know pretty well your way with the systemd units. The Fleet is more or less systemd units like a system. It supports everything that has systemd, and it has something more. So you can define just I want to run unit, which is some Docker container or anything. It doesn't have to be a Docker container, and I want it to run in my cluster. And it will run it in a cluster on any host that it chooses, and by some rules defined. And when the host that is hosting the running container or unit, it will reschedule it to run on another host. So the systemd is making sure that the units are running on your host, on one host. But if you need it to run and you have more hosts like cluster, you can make sure using the Fleet that it's running. It's using etcd for communication to just say, hey, I ran this unit and it's running on this host, and yeah, that's basically it. And there's another demo. Hopefully this one will work. So, and you should say, no, don't worry, this will work for sure. No one encourages me. Thanks. Yeah, this is a little magic because. Never mind. Yeah. So I've created another guest. I'll show you now. So what this gist is doing, it downloads the previous one, the application one. It installs Flask, like the dependency that I've installed also manually, and it's running the script that I've copied in manually. So what I will do in the Docker container on the startup, I will download this script and use it as a run script, which will do all the things for me. So yeah, normally I would just create a Docker image that's containing those scripts, but I wanted you to for the setup to be as simple as possible. So yeah, and you'd say, but you didn't show us the unit. So the fleet unit looks like this. If you're familiar with the systemd units, it's very similar. You get some unit section that's just basic information. You can specify the dependencies that it should run after some unit, or after this unit is finished, it should trigger another unit. And there's interesting part that making the things actually happen. So the exec start is executing. It starts Docker run. Yeah, that's better. It executes Docker run. It does more or less what I did, and it runs bash, which triggers which downloads the second Flask app, just a run script, and it runs it. And that's it, what this fleet is doing. There are some things just about behavior, when it fails, how often it should restart, and when it should restart. And this is different from systemd. This is the fleet part. And you are just defining the unit that is called app service. And you are saying it, because it's exporting the port, and you cannot run the two applications exporting the same port on same host. So you're just making sure that this application is not running on the same host twice. Yeah. So anytime I'll show you in demo which will work. So this is just fleetctl list machines command. Where is it? Yeah. Yeah. Can you see it? You're not saying anything. No one's complaining. And yeah, and you're just seeing there are 3 machines running in the cluster. If you want to add a machine into cluster, I think I have still some time. No. I'll do it if you have time. I'll add a machine into cluster. So now I'm submitting the unit that I showed you into the cluster. So yeah, now I really submitted the unit and actually started. So yeah, now I'm starting the unit. Yeah, so you can see the start has happened, and there's application running, and it's running on this IP address. So hopefully there will be the thing running. So it's running. It's there, and if I go to now I'll go to the host and I will kill the Docker. So you can see Docker containers running. So just kill app. So there's no image running. I'll go back to list the units, and you can see that it's actually activating and starting. No. Huh? That is some problem, Docker. Yep. So now it's running. It's running on 103, so it's yeah, again up. Oof. Yeah, and I can also run more fleet units. So I will run units 2 to 4. So you can see the unit is starting on 103. So if you go to 103, it should be up, hopefully. Yeah, it's saying hello Dockers. It's started on 102, hello Dockers 2. But there's next one which is not starting because why it doesn't have a host to run on. You know why? It's because we defined a unit to conflict. So if it cannot find a host, it will just not run it and wait till the host is available. And config, I'll say I want 4 instances of Vagrant and Vagrant up core 04. And it should give me another virtual machine, yeah, which will be Core 4, and luckily or hopefully, so we should see that join the cluster here. So it's booting up, and yeah, it joined the cluster. So now, finally, the Docker container can run also on 104. So this is how we scaled our application, just using the simple fleet. And I'm not gonna fix it. It should be working. It's probably just downloading the fleet and so on. Yeah, probably pulling the Docker image, because if you check the logs, yeah, it's downloading the image into host. So it might take some while. So yeah, I got 8 minutes, so I'll try to tell you something more about the provisioning, because you got new node, and you might like it that it's actually the same, but you might like a different same than other people's do. Yeah. So I don't know if any one of you, or probably most of you, are using EC2 Amazon, and you get a term called cloud init or cloud config. It means that on the startup of the machine, you can define some script which will happen on the startup. Or files that will be saved into the node somewhere. So this is adapted by CoreOS as well, so you can define some values, and I can give you example here. Yeah, if you want to play with that, it's in my repository. It's stored. The file is called user data, and yeah, you can set up the etcd unit custom values. You can specify where the fleet is running, on which interfaces, and what other fleet units should be started. The only thing that I've changed was that this is actually creating the systemd units for you. So you say there's a systemd unit called setIP. It's has to be started and enabled on a startup and on a machine boot. And here is the content of the systemd unit file. So it's description what I'm doing. If you saw that when I was running Docker container, I was mounting the volume etc IP. That was just because on the startup, I take the IP address from ifconfig, and I'm forwarding this value into etc IP. So you can see that every host has etc IP, which is this is the way I've customized the nodes just to demonstrate that it's possible. Yeah, and you can see that on CoreOS 4 as well, so that you can see I didn't do it manually. I did it also. Yeah, there's also it takes this IP address and yeah, prints it into etcd. You can save the information, anything you want to do on the startup, so that you don't have to touch it anymore later. And when any other joins the cluster, it will be exactly the same. And this is the way you define how same it is. So. Yeah, I think that's it. It was long enough. I hope you are not sleeping. You should cheer up now. We'll have the beverages and the meal soon. So, any questions? If you will get to the presentation in the end, is the last link is to my GitHub repo. And also, of course, you can create issues. Ask me or ask me on Twitter or whatever, or write me a message through meetup.com. So no questions? Come on, at least one question. Just say, oh, yeah.
So after my presentation, what would you say? Why should we use CoreOS or Atomic?
Yeah, they are very similar. I think the CoreOS is a bit more mature, I would say, because but I didn't touch the Atomic for a while. But for example, CoreOS, it has they have also alliance with Kubernetes. So they have project called Tectonic. So you can actually use Kubernetes on running on their hosted servers. Or there's also another thing coming. IBM and Supermicro are planning on sending just really pre-installed CoreOS machines with Kubernetes. So what you got that you get just another razor into your blade, and you just got everything you need. That's how you will be adding the new nodes into cluster, if you have the server. So you will not do vagrant up, but you will just plug it in and it will work. That's how it is always. It just works, right?